Hello, and thank you for tuning in to the Flatiron Syndicate Motorsports Podcast. This show is brought to you by Flatiron's Tuning, your source for any aftermarket or OEM Subaru parts. Be sure to check out our store at flatironstuning.com and stay tuned with Flatiron's Tuning. Welcome back, everybody, to the Flatiron Syndicate Podcast. We've got Micah from 3MI Racing joining us again here today, and we are going to talk about something that it's been on my mind for a long time. It's a tough topic, and it's come up again recently, and which has made me think that maybe now is the time to have this conversation, which is, doesn't matter which part that you buy, it doesn't matter who you buy the part from. And the short answer is yes. But it's a complicated topic. And Micah, I mean, you're kind of in like a perfect spot to have a conversation about this with. We've got a very small amount of experience with it as far as producing a product and seeing what happens and going to market with it. But there's a lot of companies out there. Well, I shouldn't say there's a lot. There are some companies out there that do not do their own work. They do not necessarily do their own research and development. When a good idea comes up, there's a temptation there to look at this thing and go, you know what, I think we can make that thing. And that's a thing, that's something out there that happens. And so I wanted to kind of have a conversation about what the impact of that is, because Micah, with 3MI Racing, your company, you've come up with some ideas to make parts work better. You've developed them on your own, and it's a good conversation. It's very relevant to your business.
Yeah, so I guess where to start? It is a very real issue, threat, if you want to think of it that way, in our current, I'll say, aftermarket world that we live in. So much so, for instance, one of the parts you carry from me regularly is the AOS train hose.
Mm-hmm.
Part of my pricing that is I price them so cheap and so low that I don't make much on them, but it's also priced so cheap and so low that it's not worth someone else's headache to go after it.
Interesting.
That literally came into my pricing of those hoses.
Wow.
All the tooling, development, fitting, all that stuff, just swallowed it. And I know I won't make much on them, but it's such a low part price. Another big shop could go out and start quoting them and be price competitive, because they could go buy, 3,000 of them at a time and be about the same price I'm at now, sort of thing. And well, then they push me out of the market.
Is it worth it?
And I'm done. Yeah. So I've tried to make it so much of a pain that it's not. And that, while it might be an approach for something that's a very simplistic part, right? It's really nothing complicated. It took some test fits, some thinking, something other people hadn't thought to do. All right, make something work better. All right, but it's a pretty low hanging fruit. You go the other end. You go to a very high end part. So, for instance, the tri-beam rods that I designed 12, 13 years ago, back when I was, pushing D-strokers, and actually D-strokers started even earlier than that. But yeah, so I did the tri-beam rod, and they caught on. A lot of people liked them, and they looked good. And then all of a sudden, copies of tri-beam rods started popping up. No one even reached out to me, say, hey, we'd like to carry your product. We do this, that, and the other. No, they decided to go and have their own, per their statement, they had their own design in-house. Said, hey, we really like this. You guys go design one over there and pop something else out. And in that case, the ones I have, most of the ones that are out there are not direct replicas. They're not exactly the same. They have some flaws in them, some other design issues that I would not have done. So it's not a direct photocopy. That's something where they did take it and design their own. There are other parts that are out there. There's a shop that is infamous within these Subaru groups, I'll say, that are known for photocopying someone's work. So legally, this goes back, I'll say this was 2010, 11, 12, somewhere in there. I was Volvo Powertrain up in Maryland. Pretty standard to go and buy a bunch of customers' engines and take them down and tear them down and see how they're wearing and how they're running and how they design things differently and what you like and don't like, and kind of concepts. Study what they did. Ooh, that's pretty unique. All right, so for instance, where it was Volvo, they have a unit injector and a big rocker arm, this whole system that runs, and it's a pretty complex little piece. Not super cheap to manufacture compared to say how International does it. International, it takes, it's stamped steel. Like stamped steel plate gets formed and it's in bending, so you have this whole big truss that's across this stamped steel rocker arm, and that's what they do. And they're cheap. They're like pennies on the dollar in compared to what we're doing. Like, well, that would make a lot of sense if we could fit that into our engine. Of course, we have to design our own. But we're going, all right, we like the novel concept. If it's a stamped steel rocker, big cost savings, blah, 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 if you can make it do the same job. But it's not the exact same rocker arm. It's still fitting our head, our valve train, our cam system, our exhaust brake system, everything else, right?
Right.
So in that regards, you go, okay, legally, you took inspiration from someone else, but made your own thing. Then there's the whole other side of things where you take someone else's product and literally photocopy it, and or
Right.
photocopy it and make one small change and say, oh, look, we flipped this thingy around. Now it's not the exact same. Though
Right.
function wise, it's the exact same thing. You literally copied it. 99% of this thing you can put in a scanner and look at it, go, yeah, that's the same
Right.
part.
And
You're not
and it's
fooling anyone.
and this is and I mean, you said just a minute ago, this was something you had in mind and you factored in when you came up with this idea of this hose, the AOS drain hose,
Mhm.
and when you decided to put it into production, that you kind of thought of you at least put thought in this direction of like, how can I mitigate this? What can I do to prevent this?
Right. And so in a low cost part like that, I could do that and know that at the same time, I'm not making as much on it as I could compared to say what market share wants. For the pricing on it, for instance, I don't think there's any room that Turn 14 would want to come to me and say, hey, we'd like to buy these by the thousands and stock them
Yeah.
to sell them at every Subaru shop. They might show up
Right.
and do that anyway. I don't know. But I
Right.
don't think there's really that room for that to happen. So, big companies looking to do that sort of thing, there's not a whole lot of wiggle room. Lower volume things in particular, like connecting rods, things like that, where they're one-off bespokes, or it's buying like 20 sets at a time, which compared to say Manly, for instance, that's nothing, right?
Right.
So 20 sets to me or 25 sets to me is a lot of money. To them, that's pennies on the dollar.
It's
That's a
almost not even
fraction
worth
of their
doing the
LS.
run.
Yeah, right.
Yeah.
So so
Well,
yeah.
from a product development standpoint, when you're, I mean, there's research and development involved in pretty much anything. And it's gonna vary depending on how complex or elaborate the part is, I'm sure.
Mhm.
But can you give an idea, like when you have an idea or think you can make a product, what is there a calculation you do for like, okay, well, this is what I think it's going to cost me to do the R&D on the part versus this is what I think it's going to cost me to produce the part, and then where does that factor in?
So the R&D on a part, let's go and say intake manifold. I've had an intake manifold that I designed again over a decade ago. Did sheet metal ones for the Turning Concepts car.
Okay.
Um, I've designed it into being a cast piece. Designed a couple different ways of doing a multi-piece, this sort of thing to try and get cost down on. I've never had the free money to go and spend the tens of thousands of dollars to get castings going.
Okay.
If I farmed out to China, probably could. Probably could get cost down significantly compared to U.S. Foundries. That's just the world we live in. The race to the
Yeah.
bottom. So if I feel like sending it to China, of course, then China can copy it, as we've seen them do with numerous other people's castings, and they
Right.
just shave off the emblem and or putty over the emblem and paint it, and they're literally selling your exact part out the door because you're not moving enough
Right.
quantity for the tooling that they have, even though you paid for the tool.
Right.
So it's a very dangerous game going that route. So you stick with someone here who you can take to court and sue if they do that, because you're protecting yourself.
Right. Right.
To have some Joe Blow shop come up after you've spent, goodness, countless hours literally running CFD studies and doing mold flow analysis and looking at all, you're checking draft angles and tweaks of every different model you're doing. So as you're doing all the CFD analysis, then you go back and check your model and check your draft angles, check everything's right, correct parting lines and all the things for your casting you're going to have. You have hundreds and hundreds of hours in doing CAD modeling and CFD and checking, draft angles and everything else that you're going to be doing for this, that once you're done and you release that and you have something that works great, and at which point we'll go and say we're skipping some steps. You still haven't done an R&D once. You still haven't either 3D printed or had investment casting done or done some other form of being able to test this, and then have the
Mm.
dyno time and have the thing you put it on and run it and go back and forth and do a couple of iterations of it because you found problems or feedback from customers or shops you partner with. Once, hey, the first 2 or 3 tests great, let me send them out to some partner shops I work with. What do you guys think? Oh, if you could change this or tweak that, blah blah
Hmm.
blah. You go through all those loops, and once all the stuff is done, you send it to the market, and to have some shop come and grab your thing and literally just replicate it and send it off to China for a fraction of the cost and undercut you.
Yeah.
This is how you lose good products in the market. You are
Right.
killing the people that actually do the work and actually have the brains to do the new parts. That's
Right.
gone.
I mean, I would almost say for a small company that the time invested, like you said, it's almost countless hours, and you probably cannot factor that, at least not maybe 1% or a fraction of a percent of the actual man hours to develop a part into what the development cost is, because it's just too great, especially for smaller companies, I would guess.
Yeah, I had done an example piece a couple of years ago just to demonstrate this. It's funny, so I got a lot of backlash for people that didn't actually read what I put in my post.
Hmm.
I had one of the IAG cast oil pans here, that
Hmm.
and their baffle pan and everything else. So I went ahead and 3D scanned it for giggles. Scanned it, took better part of an afternoon, really
Okay.
maybe 3 hours. I replicated the entire thing in CAD, posted overlay of the scan and their part within that thing. I think I put it on the Track Subaru thread. I put it on one
Okay.
somewhere on Facebook. And I should get backlash. Oh, copycats just said this. Like, look, did you even read what I said? I was
Mm,
literally saying I did this to show how little time it takes to steal someone's actual work.
right.
I've never
Right.
released a cast pan. I'm not interested in copying their thing. There are things I would do differently than they did. It's just I have a very get it all right the first time and spend it at all
Sure.
costs sort of approach versus going cast, which is it's a great part. It works well. I've seen data from guys I know who tested it, not knocking their pan at all. It's
Right.
just compared to what I would want to put on a motorsports application, very heavy.
Well, and I guess
That's
it's
just
just
me.
showing that's how easy it is. Like
Yeah.
with modern technology, like the ability to have a tool that will do an accurate 3D scan so you can bring something into CAD a few hours.
Yeah. Literally half
And
a day.
that's available. Yeah.
Yeah. I'd say between the scanning, editing the scan, pulling it in, reversing the CAD, we'll say 6 hours. 6 hours, I had their
Okay.
entire thing done. I could rip it off, send it to China, say, hey, I want these made. What's my quote? All right. I'm going to have 1,000 next month.
Whereas if you had to guess, like you have an idea for a pan, like if you had to take a guess at like how many hours, like you have the idea, you do the drawing, and maybe do some testing, how many hours do you think just by comparison that would take?
If you're starting from scratch, literally
Starting
scan
from
engine,
scratch.
scan all the different engine bays it has to go in. Do like think about it. I have to scan for GCs and GDs and
Yeah,
GRs and VAs and make sure it fits in all these chassis that are going to have an EJ engine in it, right? Make
right.
sure power steering rack and cross members are there. We know exhaust manifolds for the most part stack up. So
Yeah,
let me get a cluster of all the exhaust manifolds that I have to clear now too. Like just look at all the parts and cars you have to have just to get the collective data you need.
a lot,
Yeah,
a
it,
lot.
it ends up being a lot. And so in my
Yeah,
case, I'm doing an exhaust manifold for a motorsports application for a shop that we both know.
okay.
And so for that is why I scanned the pans that are out there because I have to package around that to make sure I don't hit.
Mm,
So I go,
right,
these are the options. And I also have both commonly known dry sump systems that are also now roughly reverse engineered into it. So I
right,
know I'm not going to crash those things.
right,
So yeah, that's why I have them. It made my life easy. At least I can grab those, scan like, 6 things and say, all right, I'm in the clear. We're good to go.
right, right.
So I
I
went
mean,
about the other way, but
couple hundred hours? I mean, would you guess? I mean, maybe more
to what? Design my
to
own oil pan?
to
Yeah.
start from scratch and like with all of the time to scan everything. I mean,
Yeah,
yeah,
if I had a shop that would take the time to have a customer's car that's coming in that an engine has to be pulled to collect the data without
wow,
proactively going and pulling an engine, right? So if I don't
wow,
want to accrue the cost of paying a tech to go pull an engine just so I can scan a cross member, then I wait until a shop, customer comes to the shop, say, hey, do you mind if when you pull your engine to scan your engine bay? Cool, sign
wow,
here. If you
right,
want to think of it that way. So if you want to do it passively as opposed to having to front the money for your tech to pull the stuff, then
yeah,
yeah, then it just line that up, pull it all in the CAD, get all the headers, which will cost you how much money to collect every header that's on the
yeah,
market
yeah.
to make sure you're going to clear it. Okay, and then time to design it. Time to design a pan is actually probably decently quick.
Okay,
Realistically, do a wet sump that's going to work properly, good baffles. Probably talking a couple weeks to go
okay,
through it all, rip it apart. If you're going to do sheet metal, a bit more work because tab slots, center fixturing, that sort of thing. So when you weld it, it actually stays where you want it to be. Casting is super cheap. That'd be a couple of days to work up the rough casting. Your baffle
okay,
system, similarly, sheet metal, depending on your method of doing it, a
yeah.
couple of days. But yeah, that is once you have everything lined up, the actual design time isn't long.
Not too bad. I mean, I'm
No.
going to say like 200 to 300 hours, just from what you're describing. Like if it's 2 weeks to design a pan, that's probably about 100 hours of time, and then another 100 to 200 hours. And this is just for rough comparison, but it's just to show like if you're going to start from zero and you're really going to do it from scratch, it's hundred
Yeah.
a few hundred hours to design a part.
And
And
in reality, if you're a shop that doesn't have someone who can design, doesn't have CAD tooling in house, so
yeah,
you're going to use a freelance engineer, a good freelance engineer to knock this out, somebody you can actually trust has history behind them, that sort of thing. You're probably talking 150 an hour.
right. Oh yeah, for sure.
Like, and you think about shop hours, that's pretty cheap. How much does it go to a performance shop now? 100, $120 an hour.
At
So now
least.
you're going to get a guy with a
Yeah,
degree in his own software and all this other background, 150 an hour. Like that's at the low end. That's somebody who's a couple years out
yeah,
of college, probably did formal SAE, is a gearhead, gets it, that sort of thing. Like,
yeah. So it's a pretty substantial investment.
yeah,
And that's the difference, and that's the conundrum because like you go into it like you when you if you have the first idea, you go into it with a lot of excitement. You might not know all of those details and how much time it's going to take, and so you go after it. You have the idea, you start doing the work, and then you come out with the part. And to anybody that's listening, I think you can imagine, like there's we've all gotten involved in something where we just spend a couple hundred hours almost by accident because you're
A
just
passion
like,
project. Yeah.
yeah, exactly, exactly. And you can only imagine what it would be like to just have then somebody come up and then go, oh, that's a great idea. I made it too, without putting in all of that effort. And that's kind of the crux of the problem,
Yeah.
I think. Um,
And it's really screams loudly when you look at someone's design. It's the exact same thing as someone else with maybe one little change.
right,
Oh, we added fins to the bottom of it, or oh, we flipped where this manifold goes, or oh,
right.
we did this little tweak.
Yeah.
Dominic Asia, a buddy of mine, longtime buddy.
Mhm.
He's notorious for doing the cylinder for cooling mod,
Right.
and he is probably the biggest guy you'll hear scream about people knocking off that concept.
Mm.
And it's happening. There are numerous shops that do it. A bunch of
Yep.
shops that carry it now. How many other shops went ahead and took the idea and went and did their own testing and their own development and said, oh, this orifice size or that size or that side, here's our data we have, and this supports why we're making it at this size, because look, we did all this work.
Yeah.
This is why it works. No, a lot of them, I've never seen anyone do that except for Dom to one extent. Dom has a couple of videos where we went and tested it before he released it. I've never seen any other shops that do it actually come out and say, hey, yeah, here's our testing. Here's why I developed it. Like, this is backing up our work as opposed to being we just copy and pasted.
Yep.
So it happens everywhere.
Yeah,
So,
that's probably a really easy example to picture for folks at home, because like an oil pan, like if I looked at an oil pan and I had to go and recreate it, like even if I had a 3D scanner, I'd be like, I don't know what all the steps I would have to take. Like, the things you're talking about going into CAD and doing all of that, that's over my head. But for a part like that, most of us could look at that and go like, I see what this is. Like there's a reasonable chance, again, without going into a whole lot of detail, that somebody could go, I think I can get all of these pieces and I can assemble these pieces myself. I don't know how many people have done that, but it's like, so like the ability to reproduce it seems easier, but like it shows that simple parts are copied, more expensive, way more complicated parts are copied. It runs the gamut of everything from small
yeah.
to complicated. It happens.
Yep.
It happens out there. And I guess the ultimate point is that for somebody that it happens to, a shop, a company, like the motivation to go out and come up with the next thing, I imagine it goes down unless you think you found a way to prevent that from happening, or you think it's too complicated that nobody else could do it, or something along those lines.
Yeah, I've got a few things in pipeline right now that I'm waiting for provisional patents before I release them to the public. And it just makes a waiting game. So everybody has
Yeah.
inferior parts for, the year and a half I'm going through all the lawyer stuff and get everything approved and
Right.
through the processes for it's 4 different things going right now. But yeah.
Well,
So
and let's talk about that, because that might be something where the thought is, oh, well, all you had to do was get a patent and then nobody can copy this thing. Why wouldn't you just do that?
if you know a patent attorney who's good and you're friendly with them, it might only cost you about 10 grand a patent.
Whoa. Okay. So it's not that's not a small investment. So you've got your
No.
time initially, and if you're going to patent it, there's a big investment in the patent itself.
And we're also skipping all the prototypes and testing as well. So
Right.
development's one thing, design.
Right.
Actually going through, and the other part of development's actually testing. And a lot of times there's iterations back to check this again, back to this, back to this. And all those times you're paying for one
Right.
off or two off, three off pieces, which are not at quantity that it's cheap enough to do. It
Right.
is expensive unless you have all the tooling yourself.
Right.
So yeah.
And is there, with a patent, just because you had the idea, what level of certainty do you have that you're going to be able to get the patent? Or is that part of what the patent attorney helps you with, is it tells you
So,
like, yes, this is a novel idea?
So initial part, you'll go and they'll do a patent, a search to see if there's, anything that's similar or the exact same idea that's been out there, to make sure that what you have is novel and new.
Okay.
And then on top of that, the lawyer kind of works the position of writing the patent so that it is exacting enough but vague enough that someone can't change one minute little thing and is now no longer your patent, but it is also exacting enough that someone can't copy the idea and execute it in other form. So it becomes that sort of thing. It's to what level you have, and then
Mm,
of course you have China doesn't care. China
right.
can copy you, and you're never going to win in Chinese courts. BMW lost this with the X5 when their X5 was copied verbatim, and they
Wow.
went and sued them. Well, sued the company, and China was like, I don't know what you're talking about. That's their own creation, and you're like, this is an X5. This is the whatever the name of the company was. I
Right,
think
right.
Top Gear had mentioned that in an old episode back when.
Okay. Sounds
So
familiar.
if that happens again, see previous mentionings of don't go to China
Right.
or offshore for that amount for that matter. But then if you go ahead and have it stateside, even then if you have a U.S. company that's copying you, you still have to take them to court. You still have to be found that your patent was infringed upon, and then judge has to go ahead and make his ruling of they owe you X amount, this, that, and the other, and cease manufacturing X, Y, Z, or they don't see it that way, and you've lost all your lawyer fees, this, that, and the other, and you get to do an appeal and try it again or whatever your process from there. I'm not a lawyer, I can't go through all that, but
Right, right.
it's not an easy thing. It's not like I have a patent, I'm protected. You have a patent, now you have to have a bunch of money to take a lawyer to go sue someone and
Right.
wait a year and a half, 2 years to get them to stop making the thing that they're stealing from you before someone decides that, oh yeah, stop making the thing that you stole from them.
This is
So
so it's a deterrent, but it's definitely not a guarantee. And the patent is only as much protection as the holder of the patent, is able to utilize or enforce the patent, I guess.
yeah.
Okay.
Another one, BlackBerry.
Hmm.
The family, the guy who invented the BlackBerry, like the initial thing, not the BlackBerry itself, ended up
Right.
taking BlackBerry to court, and the guy died before it was settled because big
Wow.
company went ahead and just buried him in legal stuff. I think it was seriously like decades long court case.
Oh man.
That the guy died before they went ahead and found that yes, you were right. Sorry, you're dead now, but your family gets everything that they essentially stole from you.
Right. I mean, there's
Yeah,
no guarantee that a court
yeah,
case will go quickly.
no,
Sometimes you watch, you hear about some kind of publicized court case that seems to be moving fast. Like that a lot of times that is not the rate that normal citizens cases go through.
right.
Um,
We're not all O.J. Simpson, right?
right. I yeah,
Get
man.
to, get to court in a hurry and take a year to
Yeah,
get through it. But yeah,
yeah,
yeah.
at least, yeah.
So
Man. Well, and that's so all these things are parts of the challenge. And like from a manufacturing standpoint, I mean, these are, if you have a business that's making a part your business and you're going to do a thing to make money. So these are all things that have to be factored in if you're going to go down the road of producing a thing.
yeah,
And so there's a lot to it, and there's a lot more to it in the design standpoint than most of us would think of. And honestly, it's
yeah,
more than I have really generally thought of,
yeah,
um, with designing a part. But it's like if you're going to actually go down the road of making the thing, this is the road you're going to go down. This is
yeah.
what you have to do.
Yeah, and you have the parts that are easy to mimic. The IAG oil pan, for instance, it's really easy. You scan the thing; it's a simple 3D part. There's nothing tricky to it. It's probably a heat treated A356. I don't know. I didn't XRF
Right.
gun it or anything to see what it was, but whatever. It's a cast aluminum part. It's pretty
It's
darn
doable.
simple.
It's
You go
doable.
to connecting rod. There's a lot more to a connecting rod in terms of stresses and stress risers and where things are. Unless you're going to copy it like verbatim, you're going to spend some good time in FEA at least replicating the idea of the concept, make sure that it's good. And again, that's even if you know what you're putting into your FEA to make it a worthwhile, load case of
Right.
anything.
Right.
And you go to things where it's, particularly get into things, say, like the hardware realm of things. You get into
Mm,
like high grades of steels, cobalt alloys, et cetera, et cetera. Unless you're going to go through and have a whole metallurgy lab to be able to go say, hey, this is what that is, and here's, it's Rockwell hardness, and it must be tempered to this, and here's the heat treat, yada yada yada. This is what we're pretty sure the alloy is done to this, that, and the other, and that's how they get this much, strength out of a head stud, for instance.
right.
Most shops aren't going to copy that. You see, there's ARP, and that's really it right now. A1
Yeah.
Technologies closed a few years ago because Lizzie Aerospace got tired of it.
Wow.
So yeah, you basically have one option now, and that's ARP. But yeah, it's a lot for someone to be able to go back and try and reverse engineer that. That's a big investment. So no one's touching that, right?
Right.
So you
Yeah.
look at the low hanging fruit and steel transmission mounts and motor mounts, and oh, that Cusco, engine mount looks really good. Let's just go and copy that and make it our own.
Right.
Okay, and yeah,
So the point here, like the first point here, is that us as customers, I mean, there's that saying that you vote with your money, you vote with your
Mhm.
wallet, and we want so we want the best part. and by best, what we generally mean is the thing that is going to give us the best result, work the best, be the most reliable, which generally means it's going to have the most development into it. Like usually the best part, usually the best part doesn't happen by accident. It's not somebody that just accidentally changed something. There's a lot of time, thought, engineering, testing behind the something that somebody brings to market, I would imagine.
And even beyond that, it doesn't have to be someone like me with a degree and they go through and do FEA. It might be someone who's just bashed their head, made 100 different forms of these on their drag car and
Sure.
realized what worked. They got to the point of what worked, but look, it cost them 100 different prototypes and all their time to get to that thing that you're now going to go replicate. What's the
Right.
cost of that guy compared to a guy like me? Yeah, I spent 2 weeks. He spent 3 years, like
Yeah.
it's still taking someone's idea.
And I think the concept here that we want to that I would want to pass on to the person that's listening to this is that you want to think about you're kind of paying forward the time that a person or a company put into developing the thing, and you're hopefully encouraging them or setting them up so that they would have enough success with thing one so that they would then come out with thing two.
Yeah.
And whereas if that is not what somebody's experience is, then the chances of them using that time and engineering and thought process to develop or focus on some other problem goes down significantly.
Yeah.
Yeah, that's the issue that we can run into, or the risk that we can run if we, instead of thinking about the best as far as the best functionality wise, think of it just as far as the least expensive option, and then there we go down that path,
Yeah.
because
Be a
most of
dead,
these, go ahead.
it can be a dead end road. You end up killing the guy who's the creator, the people that are actually making the new novel idea, the concept, the thing that works
Right,
better.
right.
And once you run
And
them out of business, you're left with the copycats who have no one to copy.
right, right. It is a complicated one for sure. And like as we're having this conversation, I mean, you mentioned the cylinder for cooling mod. I'm sure that there's going to be people that look at our website and go, well, wait a minute, you have X number of options of the cylinder for cooling mod. And one of the other hard aspects of this, from my perspective, as somebody that just sells these products and hasn't done a lot of development of a product, is how do I measure demand or work with the demand of a part? Um, and that's a challenge, and it's basically this is what the customer's demand is and what we have to supply. How do I
Yeah.
navigate that? It's
Yeah.
it's a challenge.
For me, I guess as the shop, I would always just go the person who created it first.
Right,
And, hey, we like this idea. We're looking at carrying it, and or is there a way we could license it from you? If you
right.
can't meet the supply and demand we have, can we go and license from you? We'll start replicating it. I know Turning Concepts did that with numerous products over the years, where
Hmm.
other people designed things and they started actually reproducing it for the guy and paid the people royalties for it. One
Okay.
was their like the ball joint remover. Another, if I recall, is the X brace, the back seat X brace they had for the GD chassis
Oh
cars.
yeah. Okay.
Yeah, went behind the back seat. I don't know if you recall that. They have the X brace.
Yep.
They've had numerous things like that where other people designed them. If I recall, I think they actually have the camber plates as well. Where the HVT or whatever, the offset camber plates, so they actually work properly with your street struts and springs. Unless they
Okay.
actually had camber caster adjustment.
I
Like they
don't.
had the rights to those, and
Okay.
they're not currently making them, but they have the rights to them, same
In
sort of
the
thing.
past, they did. Yeah.
Yeah, yeah. So it's one of those sorts of things. That's another way of approaching it as a shop.
Yeah.
And that's if they can't simply say, oh yeah, I can have 200 in your hands next week. But
Yeah. The for shop, I think it's an easier path because there's a different relationship between a shop that's actually working on the car, whereas we were primarily just part supply to people.
mm-hmm.
And it's something, I mean, I've honestly struggled to navigate, because there's a lot of times there's demand in another direction. I mean, without getting into specifics, there's a company that I worked with that came out with a tool that was kind of the first tool to market, and then they came out with some variations of it and it worked really well.
Mm-hmm.
And I heard they were very close to getting distribution through a big WD, big warehouse distributor,
Mm-hmm.
and then all of a sudden, talks just stopped. And a few months, like a week or two, well, probably a month or two later, another company that makes tools now all of a sudden had the same thing, but it
Mm-hmm.
was under it was a brand that already had to deal with this WD. And so there's this question of like, what
So
happened,
yeah,
and who knows? I mean, it could be anything. It could run the gamut.
I can
Um,
laugh at myself. I'd seen this was probably about a month or so ago. Life's a bit of a blur with a newborn.
sure.
Um, yeah, so a company who that makes a lot of Subaru tools came out with these cam bolts, commonly known as
Hmm.
FU bolts.
Right.
And I was like, hold on, you guys are copying such and such's thing. I know those guys. And so I get
Right.
on there like, no, we're actually licensed to make them for them. They're, I was like, oh, well, put my foot in my mouth now. Things
Right.
I was
Right.
unaware of. But
Well, so
yeah,
that'd be an example of the right way to do it.
right.
And the hard part for me as a retailer was so I had a relationship with this original company, and I didn't put the other one up, and I kept getting requests for the new part. And then what I saw and what the shop saw is that, well, there's part A or tool A and tool B, and I have tool A and I don't have tool B. I keep getting questions for tool B. Then all of a sudden, my sales of tool A dwindle, and
Mhm.
now it's like, what do you do when yeah,
I'm
it's
curious. Did,
yeah.
did did you ever reach out to said manufacturer supplier of tool A, the one that was dwindling?
Well, yeah, that's how I kind of got the backstory of like, hey, what's going on here?
Okay.
Yeah,
So
but
at least you went through the right path. You didn't just be like, all right, well, screw that guy, I can buy these and like just move them. But
well, and whenever possible, I guess whenever it makes sense, I just have all the options, which is
yeah,
it's like it's not the right answer, but it's I don't know. It's for me as a retailer, it's a hard one. What is the right answer? Because it's like there's the the seemingly obvious answer would be, well, you only carry part A that was developed and manufactured by manufacturer A, and you
hmm
don't carry any of the other ones.
well, that's also getting back to the area I was saying before. So, say for instance, someone took, say you normally carried my tri beam rods, right?
Right,
My 132.5, 4340 tri beam rods. All right, you normally carry them, but I only buy them 25 at a time. I'm sold out. It's a 12-week lead time for me to get more in.
right,
Meanwhile, you have carrier B. Say this carrier B didn't photocopy, but they did their own development of it. Slightly subpar part and design, but it's a part. People, it's the same shoe. They're happy to buy it, similar price, and you're
right,
selling it. It's not in my mind. That's not a to B. It's two
right,
separate parts, right? They
right,
design their
right,
own.
right,
Say then you go to all right. These guys have an exact copy of this motor mount, and this is B. That's where I'd say it's a moral thing. Like this was a
right.
stolen design, not a recreated. We liked it. We took inspiration from it. This is a stolen design. This is one thing. This is another. Um,
Boy, and
so
that's
yeah,
as I'm starting to think about some of these like problem widgets, and it's like, yeah, that's a really tricky one because like even if there was a patent involved and there's a difference involved, how am I to know like did you
yeah,
license the design for this from
exactly.
manufacturer A to manufacturer B,
And how are you supposed to know? Yeah,
or did you even have to because your design is novel enough that it didn't have to be licensed? Was there even a patent involved? It's hard to know.
yeah.
It's hard to know.
So
And I
I
mean,
was I
yeah,
know a lot of Subaru shops that refuse to install knockoff parts or copy parts,
sure,
and
sure.
that's their drawing. Now, a lot of them aren't retailers like yourself, so a lot of them, see the parts, they know what the parts are, they work with them hands on, hands out, and like, no, I refuse to install that company stuff. This is actually
And
made it. You can buy that, and we'll put that in instead.
a lot of times there's a reason, which is that they know that there's a difference in quality between part A and part B. Like there's
Not
sometimes.
necessarily, but yet sometimes there is. Yeah, for sure. You
Yeah.
get a cheap fly by night Chinese company that makes a knockoff of some Cusco under chassis brace thing. Yeah, chances are the welds are terrible and holes don't line up and something's drastically wrong.
Right.
You copy someone's oil pan and you sell it and the thing fits on just fine. Different. So the quality of said copy parts probably decent
Could
and
be.
probably fits
Yeah.
on just fine, but it's still, to those that know that's a copied part, I'm not going to install it because this is the person who actually developed it.
Right. Right.
So it's kind of a loyalty thing,
Yeah.
and on top of that, you have to know who actually made the thing. And again, kind of going, all right, said, company B, show me your homework. Prove to me
Yeah.
that you didn't copy them. If you're saying you didn't copy them, show me where was all the work that came out with it. If it looks the same, like no visual differences, I don't believe you that you actually made your own thing.
Right. Right.
No.
And
So,
hopefully there's a history of development from the company.
yeah.
I would
Yeah.
hope.
I would hope. Here, I saw one just the other week. When this, I kind of caused an uproar this past week over copycat stuff.
Yeah.
But a company that we know, stateside, got accused of copying another company that we know over in the UK, like both of them, and
Hmm.
they said point blank, supported why theirs was, came out. It didn't fit a billet block that they, carry from, an Australian
Right.
company that we all know.
Right.
Didn't
Right.
fit legitimately a different part. And one of my arguments that they didn't copy someone else's part is because they did do a recall. They did a big recall once they released them because they had them breaking. And if they
Right.
copied the thing exactly, they wouldn't have been breaking had they done an exact photocopy of it. So in that
Well,
regard,
yeah.
either they did a really bad job copying it, which I don't believe they did because they said they did it because it doesn't fit the billet block anyway.
Right.
So some part probably got compromised, didn't get caught, broke. They fixed it. Now they're selling it again. But
And it's one of those subtle design aspects that maybe this is where R&D comes in. Like
yeah,
if there's something to do with design or metallurgy or something along those lines,
yeah,
that has to be
yep.
discovered too.
So
It's
it does get to be a gray area. And even to someone like myself, unless you have the parts in front of you and you're looking at them and spinning them around and line, yeah, you can't always tell that.
and
Yeah,
I don't know what the best practice is. And I don't know if I could tell somebody right now what the best practice is, but I would say maybe it starts with paying attention to a company and what they're doing and what the history of that company is. And then maybe even just asking them or trying to reach out to a company and see if they can tell you, what they did to develop the part or like if they what's what their development process was. There's a handful of manufacturers out there that got really well established because they would show once the part was done and they were about to release it, they would show you a lot of the development of the part.
yeah,
They would show you
yeah,
the history, the progression, and that's probably one of the best indicators that like they're really doing the homework and the design
yeah.
versus if it just comes out of the ether and just pops up one day, it's like, well, what kind of
Yeah,
R&D did you do?
so example, I'll say myself as an example. I'm really bad at social media and all those sites. You should probably hire someone to do it because I'm bad at it. My website doesn't even work. I need to hire someone to get that going.
Oh
So
no.
if you know somebody,
Oh
anyway.
man.
But what I was going to say is, so on my Instagram, on 3 of my Racing Instagram, you can see where I started with the FA connecting rod.
Hmm.
And yeah, it starts in CAD, and I show FEA loops, and then I show 3D printed parts for just because I want to have it on my desk. I show parts in process being made. I show parts at the CMM being measured. Like this is a whole thing of where you go through all the part development.
Yeah.
So yeah, you can see all the bits and steps and pieces along the way.
I
I
mean,
mean, it's unique, so it's not like it's a copy of anyone's stuff anyway. But
would
still,
you
you show
agree
the
with that as
process.
a best practice, like from your perspective as a manufacturer? Like if you really like you know what is involved and you know what's important and you've like I've followed you. I've seen like some kind of drawing. Sometimes I think you might not even say exactly what it is, but it's like a teaser, like check this out or hold this space or something like that.
Yeah,
Would you agree that that's one of the best practices if you're going to like find a company to follow and give your money to buy a part for your car, like pay attention to what they're working on and what they're doing.
I would think so. And beyond that, it's either they can take a snapshot of the 100 demos test pieces they made, and here's how they looked, and here's the evolution of our thing.
Right.
I actually have those from certain parts at work where I didn't have sufficient data to do an accurate CFD, so it ended up being a bunch of rapid prototype parts to do this thing. It's actually while I was working at a marine company.
Hmm.
Um, so this is one component on the cooling system that I just did a bunch of mocked up parts and kind of did iterations throughout them. And I had a lineup of like 20 different things on my desk. By the time you sorted this and did that, and well, we put a thermostat in it now. This work that so going through all those iterations, they're all there.
Hmm.
If they can't show you their stack of parts that they designed and how they got to the thing that they got to, it's part of telling a story. If
Hmm.
they can't show you the FEA of something or a CFD of what they did, now a lot of people, with how cheap and approachable these things are now, anybody can put up what we like to call colors for dummies.
Mm.
So when you have the engineer on there going, those numbers are BS, pay attention because it's probably just someone made pretty pictures to go, ooh,
Could
look,
be.
it's a rainbow.
Yeah.
Uh, but yeah, so for instance, here's one. Before I had my 3D scanner, I did a bunch of iterations on the FA20 where I was putting port fuel injectors. And if you
Oh.
know, on the left-hand side, you have your high pressure fuel pump there. It's quite close to where you'd want to put a port fuel injector where the hard line comes in. So I did a bunch. I mean, I did checking angles and moving things around. I had I don't know, 10 different printed test fit parts to put in there before I got things actually aligned where I wanted. And the ID injector would sit there and I could get a fuel rail on and I'd clear the hard line coming to the fuel pump. Like I could show you the stack of parts lined up and take a picture and be like, yeah, here's one. And the pictures
Mm,
of where it failed and crashed all the way up to the one that actually worked. Of course, those
wow.
never went public because EPA came along and started, whack-a-mole.
Right.
And so
Right.
those never came out. But just the case in point of I didn't have the thing. I didn't have all the engineering stuff because I didn't have the 3D scanning stuff to copy it. So I did it the hard way. Took some rough measurements and
Okay.
started guessing.
Hmm.
So it's one of those. They should have that they could show.
Yeah.
That's other proof. I mean, start demanding it of people. If you something smells fishy, call them out on it.
The
So
the other hard thing just from us as a customer is to realize that there really is a priority to this. And that's one of the and it's like you're kind of almost paying it forward, I guess, to an extent with buying the part that has all of the engineering in it versus the part that doesn't, because we want to keep the companies that are doing the engineering around, because if you don't keep the company that's doing the engineering around, they're not going to be able to keep doing the engineering to produce these other parts. And
yeah, or just
that's
I'll just say development in general. But
development,
yeah,
sure.
yeah,
Yeah, that's the biggest risk to us as enthusiasts is that like the guys who came out with the really good thing, they might go away and not come out with any more really good things. And the hard
you
part of
make it.
that is, yeah,
It's a lot less work to have a desk job and go home at 4 o'clock every day. Yeah,
right, right, yeah, versus like getting these passion projects going and having these ideas that take hundreds and hundreds of hours, and not every one of them, I'm sure, is going to come out or be something that actually goes into production. I mean, like
yeah.
that's a path that is not a guarantee in any way, shape, or form.
I can't tell you how many times it's bedtime and you're ready and button up the house and all this done and sitting there laying in bed and brain's just on. My wife rolls over me and just tells me to like go, just go work on it, whatever it is. I can tell
Right,
you're not going to sleep, just go. And I go cranky
right,
until 2 in the morning, and I'm just banging away on something to get the thought out, to get it done,
right.
get the next iteration because something hit me.
Man,
Yeah, it's just how it goes. So
yeah, yeah. For the people that have the bug, but yeah, I mean, geez, it's that's the kind of time and effort and thought that you're supporting by supporting somebody that does that kind of work, that puts in that kind of time.
yeah,
Yeah, the hardest part here is when you start like if you're making an individual parts purchase, something that's $50 to $100, that's not maybe I'm sure that that could be a difference maker for some of us, but like there is a value in that extra, potentially $50 spent.
right.
But you start multiplying that across a whole build and multiple products, and it's now you could be talking about 1,000 or thousands of dollars of difference to go with, plan A versus plan B, and that's where it
Yeah.
becomes more challenging.
Similar that sparked a thought. Longtime customer of mine, national level autocross guy. He's got a really cool white 2.5 RS, sedan, and thing makes gobs of torque. 500 and he's 560, 580 pound feet at the rollers at like
Oh man.
3,200 RPM or something. Yeah, it's been a cool project. And he's pushed that thing far. He used to
Mhm.
run my rods, and at some point he kept pushing his work. I'm like, you need to retire my rods. He had my 300M rods. They're like 485 grams. I'm like, you're making monster torque. Those
Oh
things are
man.
just those things will die by fatigue. Like you've run them 3 years, just retire them. Time for the next set of rods.
Wow.
Um, but yeah, so he's got the point. He's run this, engine of his. Did rough numbers on it collectively. It's like 10 hours, 12 hours over the last few seasons.
Hmm.
And he's taken apart and the billet crank, 79 millimeter billet crank he has. He sent off the shop. Just kind of, I know him well enough. I'm not charging for stuff. We've got a great reputation. He's like, just want your input. What should I look at when I'm sent to the shop? Blah, 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 blah. I don't have time to do it. So I'm happy to share knowledge.
Yeah.
I was like, take this, get this crack check, get that crack check, run these, check these for straightness, check that for straightness, all this sort of stuff. Comes back, he's like, yeah, my billet crank's cracked. I won't say the manufacturer's good manufacturer. They swear that the materials they're using are actually it's US based billets that they're using. It's just one of the downsides of the geometry on an OEM
Hmm.
79 millimeter crank.
Wow.
Now, likewise, I know guys who are drag race guys here at much higher RPM making similar cylinder pressures. It's way more forgiving. At this low end,
Mm.
he's got cracks in this thing with like 10 hours in this billet crank. Now, if
Wow.
you look at the billet cranks that are out there, you've basically got this lower rung that they all hover around that 1,000 and change mark, and then
Yeah.
you go to someone who's more like the $3,000 mark, and you go, all right, well, there's a big trade off here. Here's what they have. They're oiling superior. Here's the problem with this one. There's the problem. Realistically, while this has better oiling, oiling has not been your issue. In other words, you have sufficient pressure to deal with the straight shot
Right.
design, which well, that's the technical issue for later.
Okay.
And this other one has a much better oiling design, but that's not where you're failing. Realistically, unless you change the geometry on the crank, increase the cheek on the radius for the rod bearing, lose some strokes so you actually have more overlap between the main bearing circle and the rod bearing, and this sort of stuff, that's where you're cracking. That's where you're failing. Like changing this nicer thing, which is a very similar metal. One's like a 4330 versus the others. No, an EN24B versus the others, I think a 44 or 4340. Anyway,
Okay.
But similar enough, like nothing's going to, it's not some big saving grace. It'll still be, okay, you might get 15 hours out of another one that costs 3 times as much.
Right.
Not worth it. You literally have a limit where it's a whole new design. So choosing one versus the other, it could be a Chinese one, it could be a US one, it could be somebody else's. The Chinese one is a copy of the US one. I'd say save the money. The US one would cost you $200 more. In the scheme of things, $1,000 for a crank versus $1,200 for a crank, probably not the end of the world for your build when you look at what the entire build costs. But you're also supporting the person that did the work.
Right.
So spend it.
And maybe that's a huge argument that is easy to forget is the support.
Yeah.
When you're working with somebody that has put in the R&D and you have some kind of a weird problem, they're going to have the experience so they can go like, I know what that is. I've run into that. It could be this. Like versus if they've not done the R&D, I don't know. That's weird. It must be a defect. Here's a new one or something along those lines. Like maybe
as
not even.
Or as an import guy, there's so many suppliers here that have always played with V8s, right? The big muscle cars, that sort of stuff. And they talk about, well, we just kind of copied what we knew from these because we've done for years that way, but they don't realize how different your thing is. Well, it works fine on them. Why does it work on yours? Because it's not the same.
Right.
But meanwhile, they took their years of testing data and applied it to the product. So they're that guy who went ahead and did how many iterations to get to this is why we do it this way and put this radius on that and heat treat it this way. And that went into that product, whether you know it or not. It's not that exact product. It's the 100 that they did before that. And that's how they know how to do it.
Right.
So,
I mean, it's, you hope that you buy a set of parts for a project. You pick all the pieces to the puzzle, you put the puzzle together and it's going to work. But every now and then that doesn't happen. Every now and then there's something weird that comes up and it just doesn't quite go together right, or it doesn't work the way that you wanted it to. Like that's the other advantage in working with the companies that have done the R&D is that they're going to be able to help you probably pinpoint what is going on, what's going wrong, what the mismatch might be, much more than a company that has not done the R&D.
Right.
So it's like it again, it might seem like it's a greater investment up front, and that might seem like a deterrent, but there's a lot of good reasons to do it, and you might actually benefit for spending the money, working with the company, all of those sorts of things down the road. So none of this is a simple question.
Yeah.
Which is man, what makes it so complicated to talk about.
Yeah.
But it's one of these things where it's been on my mind because it really is important, especially, you're in the game for a while and you start to see companies come up, they make some really cool stuff, and then they just kind of fade away, and you're like, well, what happened there? What's the story? And it could be a lot of things, but a lot of times it's just like, well, like they just, the demand went down because they were just fighting too much with people that were copying their designs and that sort of thing. It's a challenge.
I'll say one quick aside going back to the cranks.
Yeah.
To bring up a point. So when I say the crankshaft being, around that $1,000 mark, me having been getting material quotes for my own EJ10, which we've talked about in the past from the T-Stroker, Bonneville project is the goal for it. Getting quotes just for my own stock to do 3 off cranks, right? Just 3 cranks. I'm looking at about $1,000 a crank just in material.
Okay. Just
so to put that in perspective,
material.
Yeah, a good, vacuum art remelt chromoly that I want to use. Yeah, I'm looking at about $1,000 or $1,000.
Yeah.
$1 million. Looking at about $1,000 per blank. That's literally just a round chunk of steel that sits on my desk.
Right.
And so when people start looking at crankshafts and go, $1,200 is really expensive. They're buying that in massive bulk is how they have room for that material, and they have all the machines in house and.
Right.
So it's that's just to get perspective of, for instance, that goes back to that prototype idea, right?
Hmm.
How much you pay for a prototype? I'm paying as much just for material in a prototype as you're paying for a finished product for the guy who's
Right.
copying it.
Right.
So how many prototypes do you have to do to get the finished product before you can actually start making money?
Yeah.
It's
Yeah.
it adds up.
It's a lot. And I mean, there's definitely an argument like this is where the development of parts takes time. I mean, there's an idea, like getting the design of the idea going, but then like figuring out, all right, can we even go into the prototype phase? Like
Mm-hmm.
what is the prototyping going to cost? What is like the likelihood that we're going to be able to sell this thing? I mean, it's just there's a lot to it.
Yeah.
And the companies that have been around for a long time and that do a lot of this, I mean, they're really good at it because like this is something where like there's probably a really like you either figure it out, you're good at it, and you're able to continue coming out with parts, or like if you're not good at it, not efficient at it, like it's something where you're not going to be able to grow very quickly because there's just so much involved. But sometimes those little companies that are getting started out, sometimes that's where the good ideas are.
Yeah.
So you
Like
don't want to lose
myself,
sight
for
of that.
instance, I've got a list of, I think it's 36 projects right now
Oh my.
ongoing. But I've gotten to the point where I just prioritize them based upon cost to bring to market. Like
Hmm.
there's so many that right now there's no way I would have the money to actually bring them to market now. So I
Yeah.
have all these other ones that are lower, smaller, higher quantity sale, lower prototyping and development costs, so I can actually make that money to
Yeah.
get it going.
Yeah.
And it's a real thing. So that intake manifold, for instance, it's sitting parked. It's just
Right.
hanging out and waiting.
Right. Right.
Yeah, so it's just one of those things.
Man.
Yeah.
Okay. Well, I think we've talked very well about this issue. I can't think of another part of this that we haven't covered. Is there anything else, any other aspect of this do you think we should address before we kind of wrap it up here?
No, I think the general, concept is support the guys who make the market.
Yeah.
Yeah.
It's make the parts. If you don't
Yep.
support the guys that make the parts, they're not going to continue to make the parts. So
Yeah.
that's the ultimate takeaway, and just think of that. And yeah, that's what we I can't make rods on my own or an intake manifold on my own. So I'm reliant on the people that can. And so I want to
Yeah.
facilitate the people that can do it to have them continue to do it. So that's what we've got to keep in mind as we're doing it.
Yep.
Perfect.
So
Well, Micah, thanks very much for your time,
yeah.
especially with a newborn, that's yeah. I'd like to tell you that sleep will come soon, but I probably not. Probably not.
Yeah, probably not.
So,
But yeah. No
well,
worries.
thanks for your
Always,
time.
yeah, always good chat.
Yes, check out Micah, 3 My Motorsports, or 3 My Racing. He's got, the AOS drain hose and more stuff on the way. So I'm curious to see what those things are. So
Yeah.
thanks for your support as always. You can find 3 My products on the Flat Iron Tuning website. And until next time, as always, stay tuned to Flat Iron's Tuning. Thanks everyone for tuning in to the Flatiron Syndicate Motorsports Podcast. Once again, we'd like to let you know that your support is what makes this show possible. Be sure to check out our online store at flatirons.tuning.com for any of your aftermarket or OEM Subaru parts needs. And as always, stay tuned with Flatiron's Tuning.